Almost five after here. So again, thank you everybody so much for joining this information session on the Learning the Earth Through Artificial Intelligence and Physics Science and Technology Center's Summer RU and Momentum Fellows program. I'm Molly Lopez. I'm the Managing Director for LEAP. Um, and I think, get to introductions as we go along in the presentation, but in the interest of time, we'll just get started with some introductory slides. Okay. Yes, so again, this is the information session for the summer programs here at LEAP. We'll start, sorry, I'm trying to find the, oh, here we go. Trying to find the agenda. So we'll start with an introduction and overview of LEAP. And then we'll talk about what we will have here this summer. The research mentors are all on the Zoom with us today. Thank you all so much for joining. So we'll go through the projects that are available through the applications and answer any questions that you all might have. We'll go through the goals, program elements, eligibility, some application information, and frequently asked questions. And then we'd love to answer any questions that you all might have. Okay, so LEAP stands for Learning the Earth with Artificial Intelligence and Physics, and it is a science and technology center funded by the National Science Foundation. The strategic vision for LEAP is revolutionizing climate projections for informed climate adaptation. And LEAP's mission is to increase the reliability, utility, and reach of climate projections through the integration of climate and data science. So I'm going to play a short video that goes into a little more detail on the multiple ways that LEAP works towards its mission and vision. Sorry about that.
Change over the next several decades. And so we need to understand how we're going to adapt to that.
We know that Black and Brown communities, because of legacies of structural racism and redlining, and whose neighborhoods have resources, are already more vulnerable to, say, extreme weather events.
If we can have better predictions about what it's going to look like in the future, that helps us to sort of plan better today.
New York City, for instance, is making decisions about their transportation system right now. They're making decisions about seawalls right now. No one discipline can solve the complexities of the problems that we're dealing with.
LEAP is bringing together minds and capacities that simply haven't sat in the same room.
Climate data science is bridging the expertise of climate science with the expertise and knowledge of data science and bringing them together.
Our goal is to use all the available data out there from sensors, from satellites, and to help better inform our climate models so that we can make better predictions, so that we can help everyone adapt to climate change.
If we conduct science and we're not effective at conveying our findings to decision makers, people in communities who are going to be gravely impacted by the climate crisis, then we haven't really done our job.
That's really where we see our role as a publicly available data provider, that we are trying to lower the barrier so that everyone could get access to climate data across the globe.
That's a big moonshot to improve our climate projections, but also help inform people in a way that can also shift human behavior.
What we can say is that we're heading in a direction from vulnerability to resilience, a direction from exclusion to inclusion. And LEAP, I think, is a pioneer in this kind of effort. You'll be able to look confidently in 10 years and say, we're on a path now that's fundamentally different than the path we were on before.
All right, so this is a quick overview of LEAP leadership and committees, just to give you a sense of who's who here at LEAP. Pierre Gentine is our director. Tian Zhang, who's on the call today, is our deputy director and also leader of one of the projects. Courtney Cogburn, along with Catherine Shaw, also on the call today, leads the knowledge transfer team. We also have a corporate engagement director, Vanessa Bourbano, our data and computing director, Robert Pincus, our model development liaison, David Lawrence, who works out of the National Center for Atmospheric Research in Boulder, geoscience director, Laura Zanna, who is at NYU, one of LEAP's subrecipient organizations. We have Kukunda Kakajina and Nicole Kim, who are both also on the call today and work with the education team. Sarika De Bruyne, who works with the data and computing team, as well as Isabel Liu on the data and computing team, and me. And so now I believe I am handing it over to Candace.
Hi, yes. So I'll talk first about the LEAP education goals and objectives. So one of LEAP's education's primary goal is to drive convergence through education activities between climate science and data science, research and education and broadening participation, education research, plus knowledge transfer. We are tightly integrated with research for disciplinary convergence and training the next generation of climate data scientists. So for example, we are integrating LEAP's data infrastructure cloud platform, LEAP Pangeo, and using it to teach climate data science in our boot camps, programs, and workshops. As a Momentum Fellow, or as part of this program, there's training on LEAP Pangeo, and it will help carry out research. So education plays an important role in broadening participation through entryways. So we have been creating inclusive circular curricular materials and ensuring we have the mechanisms and resources available to support our students to succeed. So as alluded to earlier, education and research, they go hand in hand. We use relevant training for convergent research, and it ensures meaningful convergent experiences are embedded in our education programs. So an overview of LEAP REU program. This is just going to talk about some of our goals. LEAP is committed to building a diverse research community. We are bringing together climate science, data science, and climate social justice. So we care about the future of our planet and want to apply our research to help make informed decisions when it comes to the communities most affected by climate change. And these are some of our program elements. We have mentorship from a team of LEAP scientists. We offer the 2-week Momentum Boot Camp and 8 weeks of research on campus. The boot camp helps in developing necessary skills for an impactful research experience. The boot camp is not necessarily required for the fellows, etc., but the boot camp makes the researchers feel comfortable with the material they're learning. We have professional development and networking opportunities with LEAP Junior Scientist Advisory Group, community mentors, SOARs, and more. We have LEAP Thursdays, where we get together, collaborate, and listen to each other's research progress. So the Momentum Bootcamp is broken down into 2 weeks. So for first week, we have data, computing, and collaboration. Here you gain skills and you become familiar with the data set. This will be led by Adisu, a research scientist here at LEAP. But for the week 1, you're going to get hands-on experience with the climate data sets and climate models and have that first feel of what it is, what it feels like to be a climate data scientist. So for week 2, we're starting to apply machine learning and climate modeling. So here you apply machine learning to a toy data set, and this will be led by Gabrielle. And then we also have, during this Momentum Bootcamp, a terrific lecture by Linnea Hawkins class, which is called Climate Modeling 101 Workshop. So we have pre to post skills assessments that show growth. As you can see, our students felt more prepared to conduct research over the remaining 5 weeks of the program. I won't go through each line, but we have no students reporting, we don't have many students reporting level 5 skills in the pre-assessment or level 1 skills in the post-assessment. So this is terrific progress. We are here to help the next generation of climate scientists succeed and intend to provide as many learning opportunities as possible. This is a picture of our REU final presentations from 2025.
Hey, thank you,
So
Ken.
this is not me, right? Okay. So I thought.
Thank you, Candace, so much for that great overview. So now we're gonna turn it to the research project leads, starting with Encheng.
Okay, sure. Okay. I made some slides that I can share my share.
that-
Okay. Let me see. Share. Okay. Now you can see my screen, right? So see the slides. Okay, good. I'm Ensheng Wang, a research scientist from Columbia University and NASA Goddard Institute for Space Studies. So my project at LEAP this year would be global vegetation dynamics in a changing climate. So let me see. Okay, good. So we know global vegetation distribution is governed by global climate. So we have different explanations to the global vegetation distribution, and based on this theoretical analysis, we have developed a global vegetation model called BAM-E, which is coupled into GISS model E, the Earth System model, and it can predict the global vegetation distribution and the global fire distribution stuff. And also you can see the dynamical changes over time. So while at LEAP, we are going to make this model, make these predictions to be data driven. So we are going to couple it with AI approaches or machine learning approaches to incorporate the many kinds of data sets to predict what's going on with climate change. So the main purpose of this project will to explore globally the ecosystem resistance and the global carbon cycle, and then the potential for climate mitigation. So this is the purpose of this project. Thanks.
Thank you so much.
All right, I'm up next. Is that right?
Yep.
Okay. Hi, I'm Marcus Van Leer-Walke. Our project is on discovering simplified models for clouds. So I guess, yeah, hopefully you can see my screen. Basically, the idea is that like clouds are complicated. That's sort of the bottom line here. And our models, by necessity, have to be simplified to a certain extent. So if we want to predict the weather, we want to predict the climate, we have to make simplifications. We just don't have enough numbers to capture the complexity that we see. So just, looking at an average cloud, the size of the grid that we predict on is often very coarse. And so we need to represent the things that happen there with just a few numbers. So within sort of these simplified clouds also are simplified representations of like what the clouds are made of, right? Clouds are made out of little liquid droplets, and we have to make simplifications. We can't carry around every single little droplet in a cloud. We can't keep track of it. So we have to sort of statistically represent that. That requires another simplification. And then like what happens to these particles? lots of stuff, right? The cloud particles bump into each other, they become rain. Maybe they reach a level of the atmosphere that's cold enough that they freeze, they become snow or more complex particles. And the shapes of these particles are, they can be super complicated. So these are particles from a cirrus cloud that were captured and cryogenically frozen and then looked at under an electron microscope. So there's a lot of like details here and complexities in the shape of the crystals. It's basically the bottom line is clouds are complicated. We need to find simplified, ways of representing them, so that basically we can then model their evolution and predict what they're going to do to weather and climate. So that's basically going to be the goal of the RU exercise, is to dig into some detail of how clouds are represented and how we might use machine learning, artificial intelligence, statistics to represent this in a simple way. That's about it.
Okay, so I think I'm up. Hi, I'm Charles Zhang, and the projects that we're going to talk about are they're a little bit different. So I'm going to throw up the image that you just looked at, which is this one. So we're looking at the end of this process that says bidirectional knowledge transfer. So what we care about is that all the great knowledge that's developed in these projects gets out into the world in different ways. And there's two sides to a project that we're going to be working on this summer. One is what the cool kids call transmediation. So that's the idea that you would work with the scientists to translate the knowledge that they generate from one form into another. So it might be in the form of a research paper, and it needs to turn into some other form that is going to get to a different set of stakeholders. So that's one side of the project. Then the other side of the project is really working with the very end. So it's working with stakeholders to better understand what they are understanding about this work. And so those are the two kind of areas that we're going to work in. So it's a little bit different. You do need to understand the science. So going to the boot camp, digging in on the machine learning is still necessary. But then what you will be doing is helping us turn that into other formats and work with the people who are trying to understand this in the community to translate it to them in ways that is helpful to them, if that makes sense. Thanks.
My name is Kara, and I am a research scientist at Columbia in Earth and Environmental Engineering. And Joseph Coe is also going to be on our mentoring team. He's a postdoc at LEAP. And our project is somewhat similar to what Marcus described, where we're going to focus more specifically on cirrus cloud processes. So cirrus clouds are these high altitude ice clouds that form really high up in the atmosphere. This is just showing a video of sorry, let me just do this. Showing where all the cirrus clouds form on Earth, and they have important climate effects because they form high up in the atmosphere and reflect sunlight and also trap heat from escaping out to space. So they can have a pretty important role in climate, but they're very hard, as Marcus said, to represent in climate models because they're these relatively small scale processes that we have to represent at these very large scales. We do have a number of very detailed models to represent cloud microphysics. But the most accurate ones, like these Lagrangian particle-based ones, where we're actually following around individual ice crystals within clouds, are extremely computationally expensive, even though these are our best ground truth for how clouds evolve. So what we're interested in this summer is doing some work at using some generative modeling techniques to actually see if we can emulate these really detailed large eddy simulations with super droplets. And as I said, these are super detailed models of cirrus clouds. It's just showing an example of some of the individual ice crystals in these LES super droplet simulations. And we want to explore whether generative AI techniques such as stochastic interpolance can be applied to these LES simulations to emulate these state-of-the-art cloud models. And this is sort of a natural fit for this problem because these are actually models that allow you to have some ability to not just have like a deterministic prediction, but actually a probabilistic prediction. Yeah, and I don't know, Joe, if you want to jump in and say anything here as well, and or at least introduce yourself.
Yeah, I'm Joe. A postdoc, like Kara said, and I don't have anything to add, but you can feel free to reach out to me or Kara if you have questions about the project.
Oops. Sorry, how do I stop sharing? Am I still sharing?
Nope, you're good.
Oh, okay. Sorry about that. I thought I was sharing.
Thank you so much, Kara and Joe. Next is Tian and Sean.
Hi, my name is Tian Zheng. As introduced, I'm the Deputy Director of LEAP and also a Professor of Statistics in my research. And for this project, we have a pretty broadly defined vision. And then I put together a few slides just so that you know give big ideas. So the idea is that this is a bigger picture of in a perspective paper where we think about how the different data model work together in order to improve our understanding of the climate change, also create actionable insight for different stakeholders and their different aspect of it. You have observational data and you also have model data. And then on this end, you also have impact model that try to connect what climate model projection says with what preparation and action need to be taken on the human level. So this is a very big area, and we're trying to at LEAP we're trying to create individual connection to connect this together into one approach. So I often say this, like, generative AI is here, and then at one point I was drawing this picture with my student to discuss how we can leverage real analysis data and modeling data, and then human data in order to draw things together. And I asked whether AI can understand this, and AI laid out what I'm thinking about. So we're trying to leverage generative AI in our work. So we started working with something called AutoClimDS system, which is a agentic AI system for climate data science. And we are able to use it for data acquisition and data processing in a proof of concept manner. And then and then in particular, we are looking at a lot of risk assessment paper to see whether we can use this system to connect what the climate data is, and also what human need to know in order to plan ahead. So for the summer project, we're hoping to scaffold this project and also expand the project with a few different ideas, such as verifying similar generative AI tools in terms of along these veins, and also scaling it, expanding it. In addition, we also have some development needs, such as data integration, and then review what auto ML literature has in addressing some of need, and also develop statistical framework for uncertainty quantification in such systems. Sean, do you have anything to add? Oh, sorry, I forgot to introduce you. Maybe you should introduce you.
Hi. Thanks, Tian. I'm Sean Li. I'm a postdoc with Pierre and Tian. So I'll be co-advising with Tian this summer for Project File. I don't have much to add, just to say I'm happy to work with you guys in the summer.
Great. Thank you. Thank you so much. Okay, Adisu, go ahead.
Okay, let me share my screen. Can you see it?
Yes.
Okay, so this project is conducted with Yang and Bran. Yang is here in the call. Maybe he'll add more if he wants. This project, to give a bigger picture of the project, we are working on the integration part, like different parameterization is added into CSM model. So, for instance, the warm brain microphysics trained using machine learning is integrated into CSM model, and other parameterization using machine learning is integrated into CSM model. So in this project, we wanted to bring in the one of the project of replacing the existing deep convection parameterization with machine learning based parameterization into CSM. So there are some results started to be generated using this method. For instance, one of our colleagues, he's using the machine learning method and replacing the existing deep convection, and he's now in the process of analyzing the data, and he's getting some improvement in representation of extreme precipitation. So in this project, we wanted to explore this machine learning deep convection parameterization, and we wanted to see how it can improve the representation of convection and the whole process. So, what we are proposing is to analyze the CAM simulations and incorporating both the ZM scheme and the ML-based convection scheme. By doing this, we will try to understand the process of the cloud formation as well as the rainfall, including the rainfall extremes. So maybe Yang, do you have something to add, or you might introduce yourself?
Yeah, so I don't have much to say. So hi everyone, my name is Yang. I'm associate research scientist at LEAP. I look forward to working with you and look forward to get to know you and learn from each other. Thank you.
Okay, thanks.
Great. I think we're going to move into some logistics now. So hi, everyone. My name is Catherine. I'm the Assistant Director for Communications and Knowledge Transfer at LEAP. And if you join us this summer, I will have the pleasure of meeting you all and welcoming you to our LEAP spaces. And I'm just going to wait. I don't want to move into details until you can see them. Do you want me to do it, Molly? Okay. Let's see. Now I gotta find them. Oh my goodness. All right. There we go. All right. So we have about a month before applications are due. They are due on March 15th, 2026. I believe that is a Sunday. So before midnight, at the end of March 15th, applications are welcome this is for the REU program, undergrad students who will be a rising sophomore, junior, or senior this coming fall at a United States college or university. And at this time, admissions eligibility is limited to students who are U.S. citizens or permanent residents. Our application requirements are listed here. You can find our online application on our website or linked to this deck. We will make sure that you all get a PDF of this deck. Please include your resume or CV. You must include an academic transcript, and of course, unofficial is acceptable. We'd love to receive your statement of interest, describing your research goals for this summer as well as your future plans. And please make sure that you submit a letter of recommendation from a professor with whom you have studied at your home institution. We are going to hustle and review these applications after March 16th, and we will notify all accepted REU students by the end of the month, March 2026. And after we let you know, we would appreciate if you could stay within the 1 week turnaround time for you to let us know that you will be one of our REU students and you will join the project that you've been, I believe you're going to be assigned, depending on what you indicate in your applications. So you will have 1 week after being notified to notify us back. And here's a question we get a lot. I have no programming or coding experience. Can I still apply? And the answer is yes, because if you go to our website on leap.columbia.edu and you go to our education section and you look for the info page about our 2026 summer REU program, just scroll down a little bit and you'll see that we've provided you with some online resources and you can become proficient in areas that you think you are not yet proficient. And so there is time for you to gain skills along with the Momentum Bootcamp that we're going to offer at the beginning of our summer program. So you can get caught up and you can be ready to go with our research projects. We would prefer that you do not reach out to LEAP researchers directly. Please do not submit applications directly to any of the project PIs that you see here or are listed on our website. Please go through this online application process, linking and uploading all of your documents as requested in the application form. On our end, we are going to blind all applications and review them anonymously. And that's just an internal policy that we like to stick to. And then as we move forward, here are the dates. You're going to move in if you are selected as an REU student. You are going to move into Columbia campus on Sunday, May 25th. Is that correct? Yeah, not on Memorial Day. Sunday, May 25th, which is the day before Memorial Day. Sorry, if we're starting May 26th, it looks like move-in is Monday.
It is Monday, yes.
It is
Sorry
Monday.
if I might unmute.
You will move in on a holiday, Memorial Day, May 25th. And then just the next day, Tuesday, May 26th, begins our 2-week-long Momentum Bootcamp that includes the Climate Modeling 101 workshop with Linnea Hawkins. And then you'll dive right into the research projects from June 8th through July 31st. Our final presentations will be held at the end of that research period. So it'll be Thursday or Friday, like right before you move out, and move out day will be Saturday, August 1st. So just have those dates in mind. We are located on Columbia University's Manhattanville campus, and so that's a little bit north. If you know Manhattan at all, main campus is around 116th and Broadway. And so you move a little bit north of that, and Manhattanville campus is in the 125th Street to 130th Street area. And so that's where we are. And Candace mentioned Leap Thursdays. Every Thursday is kind of when we have critical mass in our office space, which is a shared workspace. And that's when we hold our Leap lectures. That's when we have a lot of our special events. And that's when you all will be able to join us in participating in those things that are regularly scheduled. And of course, we'll have special summer program scheduling as well. Stipend and housing information is here. Molly, I'm going to toss this question back to you. This last question about, can my rent off campus be covered by the housing stipend? But before that, everything else about being on campus, your weekly stipend, and certainly you reach out to us for travel support if you are accepted to the summer program. That's all there as well as on our website. Molly, off-campus rent.
Yep. The housing is provided by Columbia. So for Columbia to cover the housing costs, you would need to live in the on-campus, this building that we work with. It's really nice. Everyone has, it's a suite, you have a kitchen, and it's close to the office.
If you have questions, please do refer to our website. Again, you can just go find it on your own, or you can wait for this link when we send you the PDF of these slides. And you can always email your questions to leap@columbia.edu. And I think at this point, we're going to move into more Momentum Fellowship specific slides. Yes.
So I touched upon this previously, but these are some of the goals and program elements. The first goal, convergent research. We are committed to building a diverse research community, and we want to bring together the geosciences and the data sciences, aside from other interdisciplinary techniques. So we really believe in convergence. We believe in the sharing of ideas, reproducibility, and providing access to our research findings to other subject areas and to achieve success. So research experiences will introduce participants to transdisciplinary science at Columbia University. We have 10 weeks of research and training on campus, and there will be mentoring of undergraduate students by research scientists and postdocs. The mentorship from a team of LEAP scientists. So participants will build learning and professional relationships through vertically integrated mentoring in this world-renowned research environment. At the end of the program, the participants will participate in a final research project. So in regards to professional development and networking opportunities, the participants will engage in team learning around a meaningful project and participate in professional development activities. And we talked about this twice, so we do have the LEAP Thursdays, and the participants are usually very excited about this, and it's just a great way to bond with our scientific objectives. So I did talk about this, so I might not say too much, but just remember you have data computing and collaboration with climate models for week 1. Week 2, you have machine learning. And then at the end of week 1 on the Friday, you'll have climate modeling workshop with Linnea. And as you know, we do have this growth that we have documented through our pre and post survey. The students and the participants in these programs, they have reported remarkable growth and increase in data science applications and climate science knowledge growth. So for the applications and deadlines, who is eligible to apply? Well, we invite applications from doctoral students in data science, or it could be computer science, statistics, operations research, and related interdisciplinary fields such as communications, engineering, who are interested in a summer research immersion in climate data science. We're unfortunately only able to offer admission to U.S. citizens and permanent residents enrolled in a U.S. institution. So how do you apply? We have the online application form. Provide your resume and CSV, your transcript, a statement of interest about your research goals for the summer and your future plans after the summer. Provide a letter of recommendation from your professor that you have studied with at your home institution. If selected, when will I be notified about an application decision? So selected candidates will be notified to schedule an interview by the end of March 2026. I think Catherine has said this. You have 1 week to share your decision to join the project. And can students reach out to LEAP researchers directly or submit applications directly to the project PI? I think Molly had answered this. The answer was no, I believe, and please not. Right?
Yes, please. Can I just jump in real quick, Candice, to update the application eligibility? So yes, you have to be a U.S. citizen, permanent resident, or U.S. national enrolled in a PhD program in a U.S. institution. If you are an F1 visa holder enrolled in a PhD program at Columbia University, and you will graduate after summer of 2026, you are also eligible to apply. And Candice, I can take this slide. Fellows, Momentum Fellows, you actually will start your research work on Tuesday, May 26th. So while the REU students are spending a few days in Momentum Bootcamp, you'll just dive right into the research work through the end of the summer. And expected work hours are about 25 hours a week. And you also will participate in the final presentations with your project team. So that's you, the REU students assigned to your project, and you will present together the work that you've done with your PIs. Again, our location is at the Innovation Hub on Columbia University's Manhattanville campus. And the stipend and housing information is here. And of course, if you need travel support upon being accepted to the Momentum Fellowship Program, please do reach out to us. Here is your website, Summer 2026 LEAP Momentum Fellowship. This can also be found at leap.columbia.edu under our education section. And if you have questions, please do feel free to reach out by email to leap@columbia.edu. I think that's it for the slides. Molly, back to you.
Okay, great. Okay, thank you, everybody. Thank you, Catherine and Candace. So now we would love to open it up to any questions that anybody might have. You can feel free to unmute or drop a question in the chat if there's anything you'd still like to know. Anything else you'd still like to know. Thanks, Benjamin. Yeah. Okay, so for the summer RU, wondering if it's still possible to continue helping with research even after the program is over throughout the fall semester potentially. It is definitely a possibility, depending on the project and the research lead. We should say that there's also maybe the opportunity to present your research at a conference after the summer ends. So definitely room for continued collaboration at the conclusion of the formal program.
Colin? Yeah.
Hi, thank you so much for the info session. So I had a quick question about how the schedule would look like for accepted students. I understand that there's a boot camp in the beginning and there's an 8-week portion where you work individually with the mentors. But is the schedule with the mentors more of individual? Like, okay, this mentor is going to be doing this week, or is there like a set overarching schedule?
Okay. Molly, you want to take it or?
Candace, go ahead.
So there is a summer program schedule, which combines, so we will set forth for you lectures on Leap Thursdays at 12 o'clock, weekly mentor meeting on a certain day at 3 o'clock. We will have certain professional development things that will be put onto your what's called a summer program calendar that will be shared and expected to be, uploaded to your calendars by all REU and Momentum Fellows. When it comes to anything that is not formally put onto the calendar, like if you're going to meet with your research team, that is something that we will encourage the PIs to coordinate and to make sure that they're touching base with you or, vice versa. And in the past, we found that the students also, like between the Momentum Fellows and the RU students, we found that, after a couple of days of getting acclimated with each other, they just sort of arrange into like, hey, let's be here on Tuesdays and Wednesdays, or, let's do this in the morning, let's do this in the afternoon. And we try to incorporate some social things in there for you all as well. But I would expect that a few things will be set for you and a few meetings will be scheduled for you. And beyond that, it really is up to the students to be just almost as proactive as the PIs to make sure that you are getting the face time that you need and that you're getting the research guidance that you need.
Thank you so much.
Any other questions?
You did remind me, Catherine, that we didn't talk much about the sort of like team field trips or that are excursions that happen over the summer. In previous years, we've gone to Governor's Island, taken the ferry over to Governor's Island and gotten a tour of some really cool interdisciplinary climate presentations there. That's with the New York Climate Exchange. We've also gone over to the Lamont campus, Columbia's Lamont campus, and had a tour of the core lab, looking at ice cores that ships have taken out of various places and gone into their refrigeration facilities. It's really neat. We may be able to organize a tree ring lab tour as well. And like Catherine said, the students in previous years have self-organized field trips to explore New York City together. I think last year they went to Coney Island and obviously a ton of museums in New York City. So that's just another element of the program that has been popular. Does anyone have anything to add? Oh, Colin, do you have another question? Go ahead.
No, I'm so sorry to interrupt.
Yeah.
Did anyone else have to say anything about the trips? I'm sorry to intrude.
Okay.
Okay. So I was looking at the application and I saw that there's a section that indicates the projects that we would like to be considered for. After this presentation, a lot of the projects seem to be interesting, and I definitely don't think that it would be a good idea to say that I'm very interested in all of them, even though I am. So do you think it's possible that I include like 2 that I'm like very interested in at like the maximum, or is there like you have to only put 1 that you're very interested in?
I think you can put as many as you're very interested in. Yeah, if you're really interested, yeah, go for it.
Okay. Thank you so much. Because there was another section above it that asked like research areas, and it was very like kind of all, and it's very difficult to just pick 1 or 2.
That's good. That's a good problem to have. Yeah, you can feel free to put as many as you like.
Thank you so much. And one last question before I step off. So there was this question about previously participating in summer research experiences. Unfortunately, I haven't had the privilege to do that. But I am starting a research experience this spring. So I was wondering if I could use that space to talk about it. And like I would say other and mention the work that I'm doing this spring. Is that a possible option? Because I don't want to answer the question incorrectly on the form.
I think as long as you include that you're talking about a spring, an upcoming spring experience, that sounds fine to me. Candace or anybody feel free to jump in if you advise otherwise, but as long as it's clear, I think that's
Okay.
good to know that you have
Awesome.
experience coming up.
Thank you so much.
Any other questions or comments? Okay, well, this will be posted. This video recording of this session will be posted if you want to go back and check anything, or feel free to shoot an email if you think of any additional questions. We are here and happy to answer any questions you might have. Okay, thank you, everybody. Have a great weekend.
Thank you. Bye, everyone.
Thanks.
Thank
Bye.
you so much.
Bye.